Most atoms don't ride solo. Instead, they bond with other atoms. Now, bonds can form between atoms of the same element, or atoms of different elements. You've probably imagined bonding as a tug of war. If one atom is really strong, it can pull one or more electrons off another atom. Then you end up with one negatively charged ion and one positively charged ion. And the attraction between these opposite charges is called an ionic bond. This is the kind of sharing where you just give away your toy to someone else and then never get it back. Table salt, sodium chloride, is held together by ionic bonds. Every atom of sodium gives up one electron to every atom of chlorine. Ions are formed, and those ions arrange themselves in a 3D grid called a lattice, in which every sodium ion is bonded to 6 chloride ions, and every chloride ion is bonded to 6 sodium ions. The chlorine atoms never give the sodium atoms their electrons back. Now, these transactions aren't always so cut and dried. If one atom doesn't completely overwhelm the other, they can actually share each other's electrons. This is like a potluck, where you and a friend each bring a dish, and then both of you share both dishes. Each atom is attracted to the shared electrons in between them, and this attraction is called a covalent bond. The proteins and DNA in our bodies, for example, are held together largely by these covalent bonds. Some atoms can covalently bond with just one other atom, others with many more. The number of other atoms one atom can bond with depends on how its electrons are arranged. So, how are electrons arranged? Every atom of a pure, unbonded element is electrically neutral because it contains the same number of protons in the nucleus as it does electrons around the nucleus. And not all of those electrons are available for bonding. Only the outermost electrons, the ones in orbitals furthest from the nucleus, the ones with the most energy, only those participate in bonding. By the way, this applies to ionic bonding too. Remember sodium chloride? Well, the electron that sodium loses is the one furthest from its nucleus, and the orbital that electron occupies when it goes over to chlorine is also the one furthest from its nucleus. But back to covalent bonding. Carbon has 4 electrons that are free to bond. Nitrogen has 3, oxygen 2. So carbon is likely to form 4 bonds, nitrogen 3 and oxygen 2. Hydrogen only has 1 electron, so it can only form 1 bond. In some special cases, atoms can form more bonds than you'd expect, but they'd better have a really good reason to do so, or things tend to fly apart. Groups of atoms that share electrons covalently with each other are called molecules. They can be small. For example, every molecule of oxygen gas is made up of just 2 oxygen atoms bonded to each other. Or they can be really, really big. Human chromosome 13 is just 2 molecules, but each one has over 37 billion atoms. And this neighborhood, this city of atoms, is held together by the humble chemical bond.